Good morning guys. Today we are doing geometry and we are going to discuss about a theorem which is the Stewart's theorem. Now this is a really beautiful theorem, and the reason being you have got theorems regarding right triangles, you have properties of isosceles triangles, you know about equilateral triangles, but especially when you get a scalene triangle it is kind of very confusing as to how to proceed with the sum. Now this Stewart's theorem, basically the theorem is about scalene triangles and you can adapt it to suit isosceles triangles or whichever type of triangles you might be having. Now this theorem I have not seen mentioned in any of the syllabus. Syllabus is meant for students, but then this is a very basic theorem, and if you are practicing for competitive examinations or if you are really interested in geometry, you should definitely learn this particular theorem. Now let us get to the statement of the theorem first, then I will be doing the proof of the theorem, then a few basic sums. Now there are tougher sums in Stewart's theorem and I frankly do not think it is meant for class 6 or 7. 8th upwards I can definitely try it out. So I am uploading those sums as a separate video. Okay, so now let us start with the class. Here you have a triangle. It is a random triangle. It's a scalene triangle. I have named the triangle ABC and the side length is B. Normally we use the same alphabet but in the lower case to represent the side opposite the angle. This is B and this is C, and this whole length is A. You have a line that is starting from the vertex A to the opposite side. So what is this line called as? This line is called as a CVN. I hope you have come across this particular word. If you have not, CVN is a line that intersects a triangle's vertex and the side opposite the vertex. Okay, so this line is intersecting the vertex A and the side opposite the vertex BC. Now can you tell examples of CVN lines? You have something called as a median. You have angle bisector. You have altitudes. These are all examples of CVNs. Now, in this particular diagram, this is a random CVN which is drawn from the vertex A to BC. It is dividing BC in the ratio MN, which means that this length is M and this is N. Now, the side opposite A I am denoting by the small letter A. So, from this, what do you know? You know that A is equal to M plus N. Okay. Now, according to the Stewart's theorem, suppose this length is D. Okay, according to the Stewart's theorem, B square M plus C square N, okay, is equal to A into D square plus Mn. A little long theorem. Now there is a mnemonic which is mentioned. If you Google it, you can find out there is a mnemonic that they used to remember this theorem very easily. This is a mnemonic that I have come across. Man plus dad is equal to bomb plus sink. Basically, a man and his dad put a bomb in the sink. So that is what they use as a mnemonic for this. So man. So when you open this bracket, A in AD square plus MAN. Correct. So man, dad, DAD dad, BMB bomb. B square M becomes bomb and sink. This is a mnemonic that they are using. Man plus dad is equal to bomb plus sink. If that works for you, you can use this mnemonic to remember the theorem. It totally doesn't work for me, but then it is left to you as a student to adapt to whichever method you find easier or comfortable. Okay. So now that you know the statement of the theorem, now let us see the proof of the theorem. Now in geometry, whenever you study theorems, you have proofs, not always, because when you studied Pythagoras theorem, I don't think you ever studied the proof in grade 7. You studied the proof of the Pythagoras theorem for the first time in grade 10 by using similar triangles, I guess. Now, this particular theorem, I am telling you the proof because the proof is by using Pythagoras theorem. There are other proofs also by using trigonometry, but I will be using Pythagoras theorem to prove this. You can go through the proof, understand it, because whenever you study a theorem, it is always better you go through the proof, understand the process so that the application of the theorem becomes more effective. Now, if you do not wish to go through the proof, you want to learn only the statement and apply it directly to the sums, please do it. Okay? Okay, in this particular diagram, this is our CVN as I already mentioned. Here you can see that the length N is greater than M because That is how I have drawn my CVN. Now let us start the proof. Drop a perpendicular from the vertex A to BC. So AH is my perpendicular. Okay, I am marking the length of AH as H. Now this particular point DH I am marking as Y and CH I am marking as X. What is the length of CD? CD is equal to N. We already mentioned that this line is dividing it in such a way that BD is equal to M and CD is equal to N. Now CD itself, this altitude is dividing as X and Y. Okay. Now I have a right angle triangle here. Check the triangle AHC. Okay. What do you see? You can say that B square is equal to H square plus X square. Right? Now what is X? X is actually N minus Y. So I will write H square plus N minus Y the whole square. Okay. Now what is B square M? The reason we are taking B square M is because the LHS of our theorem had B square M. So B square M becomes M into H square plus N square minus 2NY plus Y square. Okay. Multiplying with M, what do you get? MH square plus MN square minus 2MNY plus MY square. Let this be our first equation. Now check the right angle triangle AHB. Okay, so triangle AHB. In triangle AHB, you can say that C square is equal to H square plus M plus Y the whole square. By that I mean this particular length. Okay, so if I open the bracket, I get okay. Now C square N, I get H square N plus M square N plus 2MNY plus NY square. Okay. Now the LHS in my theorem was B square M plus C square N. So I will be adding the first equation and the second equation. And let us see what we are getting. So 1 plus 2 will give me B square M plus C square N. Correct? Now MH square. Okay, I will just write down C square N over here so that it is easy for us to understand what we are adding. C square N is equal to NH square plus M square N plus 2MNY plus NY square. This is our second equation. Now you can see that 2MNY with a negative sign and a plus sign, so it will get automatically cancelled. Okay. Now let's add MH square and NH square. H square is common, so I will write H square into M plus N. Okay. Now Mn square and M square N. What is common in that? Mn is common. Correct. Now My square and Ny square. Y square is common. M plus N. Okay. Now M plus N is a common term on all the three. So M plus N into H square plus Mn plus Y square. Now H square plus N square should give me D square because this is also a right angle triangle. So this becomes this is our theorem. So we have done the proof of Stewart's theorem. Now I told you what a CVN is and how to find the length of a CVN by using the Stewart's theorem. Now what happens when the CVN becomes the median of the triangle? So CVN is any line that joins a vertex of the triangle to the side opposite to the particular vertex. So I told you that median is a CVN, correct? So this is my D. So what happens? This side is equal to this side, correct? So what was my Stewart's theorem? My Stewart's theorem was B square M plus C square N is equal to A into D square plus M into N. Correct. So M is equal to N over here. So let us take it as M itself. Oh, you can take it as N itself. So one value you take. So I am taking it as M itself. So this equation becomes b square m plus c square m is equal to a into d square plus m square. Now you know that this is a is actually m plus n. When n and m are equal, this becomes 2m. So this is 2m into d square plus m square. Correct? This is m into b square plus c square. M is common. I can cancel. So b square plus c square is equal to 2 into d square plus m square. This is a theorem which is known as Apollonius theorem. This theorem helps you to find the length of the median for any triangle. So from the Stewart's theorem, which was meant for finding out the length of the CVN for any scalene triangle, we have moved on to the Apollonius theorem, which tells you how to find the length of the median. Okay. Now we see how Stewart's theorem can lead us to the Pythagoras theorem. Now let us take the case of the triangle when B is equal to C, or we are taking the case of an isosceles triangle. So when B is equal to C, what happens to the Stewart's theorem? It will become 2b square is equal to 2 into d square plus m square, or I can say b square is equal to d square plus m square. You know that in an isosceles triangle, the median is at an angle of 90 degrees to the base, or median and altitude to the base are the same. So this comes at a 90 degree. So this becomes a right angle triangle. In the right angle triangle, our Pythagoras theorem states that b square is equal to n square plus d square. In this case, m and n are equal. So d square plus m square. So that is what we are getting. See, when you are studying, this is just meant for understanding and how a particular theorem can be used to derive other theorems. When you are studying, study the Stewart's theorem. Understand Apollonius theorem is meant to be used when this particular CVN becomes the median. So in that case, m is equal to n. You don't have to study this particular formula. You have to study only the formula for Stewart's theorem and apply the condition. But understand that it is called as an Apollonius. It is called Apollonius theorem, and Pythagoras theorem you obviously know. I just mentioned how to derive the Pythagoras theorem from the Stewart's theorem just for understanding purpose. Okay. The last sum that I uploaded in the previous video, we had done it using the Pythagoras theorem. At the point of time, I had mentioned that there is one more way of doing that particular sum, that is by using the Stewart's theorem. Now we had to find out the value of the segment, of the length of the segment, or the value of x over here. So let us use the Stewart's theorem. So you know that now CB is my CVN, which is equal to D. So let us start applying. So this is my M, this is my N, M plus N is equal to A, and this is my B, and this is my C. Correct? So let us start. It is 8 square into 2 plus 7 square into x is equal to A into A will become x plus 2 into 7 square plus 2x. Okay. Now let us open the bracket over here. You will get 128 plus 49x is equal to 49x plus 2x square plus 98 plus 4x. Okay. Now we will get 30. 49x gets cancelled is equal to 2x square plus 4x. So x square plus 2x minus 15 is equal to 0. It's the same quadratic equation that we obtained in the previous class. Solve it in order to get the value of x as, I guess, 3. Okay. Fine. So now let us move on to a few more examples of application of Stewart's theorem. Here we have our second sum in Stewart's theorem. In an isosceles triangle with two sides measuring 17, a line measuring 16 is drawn from the vertex to the base. If one segment of the base as cut by this line exceeds the other by 8, find the measures of the two segments. Try it out. It is a direct application of the Stewart's theorem. You might maximum end up with a quadratic equation which you will have to solve. So let us start with the diagram. Isosceles triangle with side 17. I have a line of length 16 which is drawn to the base. We do not know, nothing mentioned about whether it is a median or anything. It is just a random CVN. One segment of the base is cut. So if this is x plus 8, this is x. Okay, now let's apply the Stewart's theorem. 17 square into x plus 8 plus 17 square into x is equal to x into x plus 8 into 16 square plus, sorry, this is x plus 8, x into x plus 8, which is b square m c square n. Okay, now this is my a is this total length x plus 8, this is d square and this is m n. Okay, now let's open the bracket and solve this equation. So I get 289 into x plus 8. So 17 square is a common factor in this, so I will take it out. So I will get x plus 8 plus x. This is equal to x plus 8 again into 256 plus x square plus 8x. Okay, now you can see that x plus 8, it is a common term, but then when you are actually solving sums, please do not cancel of the variables, thinking since they are both on since they are there on both the sides, I can cancel it out. The reason being 3x is equal to 4x square. Okay, now if suppose you are cancelling out 1x, what do you get the value of x? X is equal to 3 by 4. So you got one value for x which is equal to 3 by 4. But what was my original equation? My original equation was a quadratic equation for which I am supposed to get two solutions, correct? So 3x is equal to 4x square. Suppose I am transposing 3x, this is what I get. X into 4x minus 3 is equal to 0. Or x is equal to 0 or x is equal to 3 by 4. I am getting two values as required by the quadratic equation. So whenever you are seeing common variables on LHS and RHS, please do not cancel it when you are actually solving a sum. If you have to find out the value of x. In this case, because I have to find out the value of x, I am not going to cancel it. I might get an invalid value, but still I am going to return it and then solve the equation. So what do I get here? This is a common factor. So that is 2x plus 8 is a common factor. I take it out. Is equal to a 0. Okay, this is what I am getting. Now let me erase this so that I get some more space to do the sum, and then we will get back to solving the sum. So you can see here that I have taken out 2x plus 8 as a common factor, and this is the equation that I am getting. Now a into b is equal to 0, either a is equal to 0 or b is equal to 0. So either 2x plus 8 is a 0 or this is a 0. Now 2x plus 8 is a 0. What happens to x? X becomes minus 4. Now minus 4 is not possible because x is a length. So this is not our answer. So this part has to be 0. We have a quadratic. We need to solve it. I have solved it by using split terms. So I am getting the value of x is equal to 3. I cannot take x is equal to minus 11 for the obvious reason as this. Okay. So now we have found out the value of the segment x. Now the other segment was 8 more than the previous segment. So this is 11. So the measures of the segment are 3 and 11. Okay. So now we are at the end of today's lesson. So we have learned actually two theorems, Stewart's theorem and Apollonius theorem, and how Pythagoras theorem is a special case of Stewart's theorem also. And we have done a few sums which I feel it is very basic. It's a direct application of the Stewart's theorem. Only the calculation took a little bit of time because they were quadratic. Now if you want more complicated sums in Stewart's theorem, I am uploading one more video on only the sums applicable to Stewart's theorem. They are a bit more complicated than we have already done. So if you are really interested in learning more about those kind of sums, please wait for my next video, which I will be uploading by, let us say, in the next 2 days. Okay. So till then, keep practicing, and also any doubts, you know where to mail me. So ask me for more questions if you need them. Till then, bye.